All right, girls, this is homework for section 4.4. We did 3 problems. We're just going to go through them. I'm going to go through them kind of quick-ish because some people are done with them, but here we go. We're trying to find absolute max and absolute min of this guy on this closed interval. Okay, the first 2 are closed intervals. The last one is the open interval, so going all the way across like negative infinity to positive infinity. Okay, all right, so this guy, all right, when I go to do my boxes, I'm going to have 2 endpoints, so 0 and 6. Where do we start? Let's do that.
Start with critical numbers.
Critical numbers. How do you find those? Derivative. Okay, let's do it. 8 minus 2x, okay, equal to 0. I'm going to bump the 2x to the other side.
Yep.
So 8 equals 2x. My critical number is 4. Okay. Then did you do your table?
Yes.
Cool. Okay. Let's do table. But instead of going negative infinity,
We go 0 to 4, 4 to 6.
0 to 4, 4 to 6. Yes.
Then we use numbers 1 and 5.
0 to 4, 4 to 6. You guys use 1 and 5.
I use 1.
1. That sounds as good as any. Yep.
Positive, negative.
Test point. Okay. We plug it in. Where do we plug them into, by the way?
The derivative.
The derivative. Okay. The derivative is 8 minus 2x. That's the derivative. F prime.
8 minus 2 is positive.
Okay. So if I plug 1 in, yeah, 8 minus 2 is positive. Cool. So that means he is, what does that mean?
Increasing.
He's increasing. Okay.
And then 8
And
minus 10 is negative.
Negative, so he is decreasing. Okay, so he's increasing, then he's decreasing. Okay, so here's the deal. We have a maximum, and this thing's gonna look like a parabola. We can kind of like put our ish knowledge to this. We know he looks like a parabola. He's a downwards parabola. So this guy is not only a maximum, but he's gonna be the absolute maximum, right? Because he's going to be down on both sides, okay? So I have an absolute max at what? 4 comma something. We got to find that something, right? So we plug him into the
For the
original, okay?
That's 16.
So 8 times 4 is 32 minus 16, 16. Yeah, 4 comma 16 is my absolute max. Okay, now we've got to decide, these 2 are my minimums, but are they both absolute minimums? Is one a relative minimum? Like, how do we find that?
Since it's a negative number to a positive quotient, or an even quotient, or not quotient, what's the term? Exponent. Isn't it just no abs min and only abs max?
But he does, so if he would continue on forever this direction, Josie, in this direction, he would not have an absolute minimum. But because he's on a closed interval, where like 0 and 6 are end points, we will have an absolute minimum. Okay? But how do I find out which one is lower than the other?
We don't.
Plug them in. So 0 comma something and
So
6 comma something.
0, and 6, 12.
Yeah, 0 if I plug in is 0. 6 times 8, this is 48 minus 36, so 12 you said? Okay?
Yeah.
So which one's lower?
0, 0.
0, 0. That's my abs
Min.
min
And then we have a relative min.
at 0, 0. Yeah, then we have a relative min at 6, 12. Do we have to say that?
Yes.
We do?
No, I don't know. I'm just writing it just
Okay.
in case.
Sure.
I don't have my book.
I think they only need absolute max and min on the interval and state where those values occur. So we did relative min. Great. That is all of our extrema stuff. Okay, good? Happy with that?
Yes, I'm gonna go to the bathroom.
Okay, perfect. Number 10. We do have a closed interval here as well. Where should we start? What should we do first?
Critical number.
Critical numbers. Okay, derivative. 6x squared plus 6x minus 12. Okay, now what?
Divide by 6.
Yeah, let's do.
Set equal to 0. Divide by 6.
Yeah, let's just divide everything by 6 and throw it in the garbage, right? So x squared plus x minus 2 equals 0. I can do that,
I'm
right?
just trying to find maxims and mins in this one.
Absolute max and absolute min. Yep. So this guy is a simple trinomial. Can you multiply to get negative 2, add to get positive 1? Yeah, plus 2 minus 1?
Yeah.
What?
This one has parens.
This one, number 10 has parens? Does it really?
Pretty sure.
No, it doesn't. They're both brackets. I'll touch on that here in a second, though. So we'll talk about if it is parens, then this occurs. Okay, so if we set those equal to 0, my critical number, one of them is -2, the other one is +1. Okay, so how many test intervals am I going to have? I heard Eli say it. 3? Okay, what's the first one going to go from, though?
-3 to -2.
Yeah, -3 to -2, because this is my endpoint, right? We're going from -2 to 1. Oh, these are going to be ugly.
Yeah,
And then from 1 to 2. Gross. So the middle one I could use 0, right? But the other one I've got to use like -2.5 and +1.5. Okay, but we're going to make it nice here in a second. This is my test point. Okay, where am I plugging into? The derivative. Okay, the very, very broken down derivative is x plus 2, x minus 1, right? Okay, I can get away with just plugging these guys into x plus 2, x minus 1 and figuring out plus minus, yeah?
Mm-hmm.
So if I plug -2 into -2 plus 2, that's going to be negative, right? -2 into -2.5 minus 1 is another negative. So that's going to be plus, so he's increasing here, yeah? Okay, 0, if I plug 0 in, 0 plus 2 is plus, 0 minus 1 is minus, that's going to be minus, so decreasing, yeah? Okay, so these numbers aren't that bad because we're not actually looking for a number. We're just looking at plus minus. That makes it nicer. Okay, 1.5 plus 2 is plus. 1.5 minus 1 is plus. Plus plus means plus, so increasing then.
Yeah.
Okay, okay. So we really have like kind of 4 points that we have to look at, right? We have this dot right here, this dot right here, this dot right here, this dot right here, right? Okay, now this dot, this left dot is at -3 comma something, okay? This dot is at -2 comma something. This dot right here is at 1 comma something. And this dot right here is at 2 comma something, okay? Now, when we're doing all of these things together, we're trying to find absolute max and absolute min. We've got to plug them in. We've got to figure out which ones are highest and lowest. And that's our abs max and abs min. If, Reese just asked this question, if this was a parenthesis and this was a parenthesis, what that would mean is that on my graph, this is not a closed circle, this is an open circle, so we no longer need to look at those 2 points as being points on my graph. I would only have those 2. Does that make sense? That's the difference between the 2. Okay? But since these are brackets, we do have physical points there, so we have to plug them in. All right, this guy is increasing, decreasing, increasing. So this one's going to be a max, and this one's going to be a min. But then we've got to figure out like which one's the abs max and abs min and all that good stuff. Okay, this guy is going to be a min right here because he's down, right? And this guy is up, so he's going to be a max here. So we got to figure out of the 2 mins, which one's the lowest, of the 2 maxes, which one's the lowest, right?
It's -3 comma 9.
-3 comma 9.
-2 comma 20.
Okay, and you're getting these by plugging these into the original. Just making sure. Okay, -2 comma 20. Okay, 1 comma.
-7.
Okay. Yep.
And 2 comma 4.
That's all what I got too.
Awesome. Cool. Okay, so my maxes. Do you guys understand why I know that this is a max and this is a max?
Yeah.
Just by the direction of everything going? Okay, so out of those 2, the highest one is at 20. So my abs max,
Is -220.
yep, is at
Yep.
-220. There you go. There's my first one. My abs min,
Is at 1
1
-7.
1 -7. You were right.
Look at us go.
Okay, and then the other ones are just going to be relative, which we don't necessarily have to write down. But there they are. Got it?
Yep.
Okay. Perfect. Beautiful?
Yeah.
Yay. Okay. All right, this one has to do with what Josie was just talking about. Okay, what's this guy's parent function? He's backwards.
Oh, because he's an he's a negative.
He's a negative x squared, which means he's going to be a parabola, which means he's going to have and he goes from negative infinity to positive infinity. So these don't stop. Like they don't have points. They don't stop. He is going to have a
abs max, but no abs min.
abs max at this thing, but no abs min. Will he have a relative min?
No.
No, he won't have anything else. He'll just have those guys. Okay, so let's find that place. How do we find that?
Start with our critical numbers.
Critical numbers, derivative. I'm going to put him in order. Can I do that?
Yeah.
So this guy would be negative 4x. This guy would be minus 4, and then nothing, right? Equals 0?
Yeah.
Buh. What is that? Negative 1?
You could take 1 plus
Is it
x.
positive? No, it's
You
negative.
could take out a -4.
You
1
could,
plus
and then it'd be
x.
x plus 1, right? And then it'd be -1. So that would work, right? So -1 is your point. Okay,
Negative
so
infinity to -1 and -1 to infinity.
negative infinity to -1. Now, you could, if you didn't want to have to do the whole table thing and do the test point thing, we know -1 is going to be an absolute maximum just because we know what the parent function is, right? Like we know what the parent, so we wouldn't even have to do this table. We could just say it's that I have a maximum at -1 comma something, right?
Yeah.
That would work, okay? Whatever, it doesn't matter.
Negative
If
2
you
and
did the
2
table
minus increase decrease.
and you did -2 and I could do 0,
Or yeah. 0
whatever. My derivative is -4x minus 4, so this would be
Increase.
plus increase. This would be minus decrease if I plug them in.
-1 comma
Increase,
5.
decrease. -1 comma 5, you said?
Yeah.
If you plug it back into the original, there he is.
Yeah.
That's it. Absolute max at -1, 5, no min.
Yeah.
Yeah, not too bad. I feel like this stuff is less than what the
This is-
last stuff was.
Yeah.
Just
Less
because the derivatives weren't that bad.
Yeah.
Like when they give you quotient rules and then a chain rule
Those
inside of a
are
quotient,
worse.
it's just like, and then the algebra is all stinky. Like the concept itself of doing this table format and doing all that stuff, like you guys have that down. But the derivatives in the inside just make it really disgusting and then you lose where you're at and whatever. So anyway, so that's it. Okay, good?
I wish
All right, I'm gonna
Harry
stop this
Potter
video.
were out of this.